very much. Again, my name is Deral Heiland, and the talk is it's all. So, if you haven't seen me speak before, you will find out typically when I present a topic, my goal is not to answer all your questions. My goal is to actually make you walk out of here asking more questions. So I hope you like that approach. So we're going to be talking about some interesting things. Quickly, history of me. My name is Deral Heiland. I work for Rapid7, currently as their research lead focused on IoT-based technology. So I've been in IT for over 25 plus years. I've been in security for 15 plus years. And for the last 8 or 9 years, I've been working as a consultant pen tester. My goal is to go into various companies, carry out red team exercises, penetration test exercises, break into networks, that type of thing. But on the side, generally, I've been doing research for over a decade. So I'm fascinated about finding vulnerabilities, how to develop those vulnerabilities in the real attack methodologies against companies and organizations, and to teach you guys how these work so that you are aware of it as maybe pen testers or blue team kind of guys, so you can protect your environments. So we're going to dive into this presentation. We're going to start off with a quick agenda. So we're going to go over kind of why I'm here and how this all started. We're going to talk about web-based technologies. We're going to talk about web security and the lack thereof, and I think we're all very familiar with the lack of security in a number of web-based technologies out there. But we're going to look at it from a very different perspective also. We're going to look at injection attacks against various products, against embedded devices. We'll have a few examples. I have like 3 videos. Maybe if we have time, I have a 4th video I'll show. I know the 4th video, the guys here from Rapid7 will love that one, because I attack our own products, and I find vulnerabilities in our own products once in a while. And then we'll have a conclusion and, of course, questions. But on the questions thing, throughout the entire presentation, do not hesitate to ask me a question. If you don't understand something, please let me know and I'll explain it. I think we have time to do that, and I want everyone to have some good knowledge coming out of here. And I want you to learn, and I want you to have fun. So you'll find out I get very excited about what I'm talking about. This is kind of a thrilling subject to me. It's a lot of work I've done, a lot of evenings, a lot of nights. I do research typically on Friday nights. Outside of my research work all day at my job, I start projects on Friday night at 11 or 1 to 3 in the morning. I do that every Friday and Saturday night. So I'm always got multiple projects, research projects I'm doing for the mere purpose of sharing with you guys. So let's go ahead and get started. So why? Why am I here? What are we talking about? In this case, we're talking about non-traditional deployed web servers that are ignored. So what am I talking about? We're all familiar with the internet and all the web services out there. We're always hearing about cross-site scripting and SQL injection and all these type of attacks on that based technology. But what about other technologies? What about embedded devices that have web servers? I also like to search and find simple and obvious attacks. So everything I'm going to show you today is not rocket science. It was really simple to find. And some of these are so obvious, it's scary obvious, at least from my perspective. But a number of times we don't necessarily think about those obvious things. We're always looking for that complex, secret way attackers do things. But I'm going to show you some real simple things, real simple attack methods that we're able to leverage against embedded devices and also against management type applications. So let's start off with talking about web technology. When I was talking about embedded technologies, we're talking about appliances that are on your network. We're talking about IoT-based technology, the new upcoming IoT stuff, okay? All of these devices appear to have web servers. Literally, every device on your network, plugged into your network, that is not a desktop, laptop, or server, more than likely has a web server running on it. Whether you believe that or not, they do, all of them. Everything from a printer to your IP cameras, to your fax machines, whatever you're using is plugged into your network, more than likely has a web server on it. The second area of attack is against management software. So think about this. Every time you, as IT professionals, security professionals, go to manage some service on your network, let's say it's some network service, you're going to manage all your devices on your network, and you're using a network management system, whatever that may be. How are you interacting with it? 9 times out of 10, you're interacting through a web interface. This is part of the off-the-shelf product. Security products. Most of Rapid7's products all have web interfaces. Almost every product out there that is a security product has a web interface that you interact with to manage that product. These type of devices, these type of technologies have the same problems, same vulnerabilities that we see in all the e-commerce stuff on the internet. But no one's paying attention to, or very rarely paying attention. And of course, the last one I mentioned there is kind of device type tools. An example would be the printer. You have a tool to manage all the printers in your environment. It's probably going to be a web interface to manage all that. And so is that true?
Oh, yeah.
Yeah, it's exactly true. So I have one more question I almost forgot to ask before we start going. I would really like to get a feel for the audience. So how many people here are managers? Whether IT or security managers. So how many of you are practitioners? The rest of you practitioners? So out of the practitioners, how many of them are blue team? Blue team type deals, okay? How many of them are red team, kind of hackers, pen testers, consultants? So we have at least one in the audience. Well, that's kind of interesting. I kind of like that. I'm often talking to a lot of pen testers, and they understand this stuff fairly well most of the time. So I like the idea I'm talking to practitioners, managers, and blue team driven people, because I think you need to know this stuff. And at the end of this, we're going to have some challenges, things that you can go back in your environment and take a look at. So the name of the presentation was It's All in the Name. So every time you, after this presentation, log on to any one of these management consoles and see a name on the console for a device, remember how that got there, you're going to look at it very differently. That's what I'm hoping. So is everyone awake?
Yeah.
Did you overeat your meal? Just want to check. So let's dig in a little deeper. Here's a screenshot. This eye chart here was a snapshot I did during an assessment. This was on a fairly large company, but it was only done across like 10 Class C subnets, and it was only about 1,000 devices were actually valid within those 10 Class C subnets. These are all of the different web servers running on that network. This is a snapshot of your environment. I guarantee you, if you run a scan of your network, pull down the data of the actual device types, the server type, you're going to see stuff like this. I mean, look at all these different patches. And then we have all these embedded device type devices. Happy ICS server, it's a web server. I don't know what that is. Does anyone here know what that is? But you can see all of these different web servers. So we're not looking at just Microsoft IIS and Apache, but we have all these different web servers that are running on your network, potentially exposing you to various attack vectors. These are the common vulnerabilities we see. Cross-site scripting. So does everyone here know what a cross-site scripting is? Anyone here not know what a cross-site scripting is? Okay, so that's a pretty good answer there. I did a conference not too long ago where about half of the people in the audience didn't know what cross-site scripting was. So, these were IT professionals, but not necessarily security professionals. So I went ahead and explained it. What about cross-site request forgery? Everyone understand cross-site request forgery? Anyone not understand cross-site?
I know what it is. I don't fully understand it.
Okay. So the best way to describe a cross-site request forgery, and it ties in real heavy with cross-site scripting. And what it's leveraging is the fact that the person that you're attacking, his web console, his browser, will most likely have some kind of elevated rights. He may be an administrator. So an example is, he's an administrator on a product. So he logs in as administrator. You send in cross-site scripting attacks that leverage the fact that he has administrative rights on something. And you leverage that to get him to carry out transactions for you with those injection attacks. So you send the cross-site scripting, and using the whole concept of cross-site request forgery, you forge his request onto a system and execute a transaction. We're actually going to have a video showing a cross-site request forgery type attack, where we're actually going to use it to create an ID on a management system.
Okay.
So we'll show that so you get an idea of what that is. So does that make sense to everyone? Okay, good. And then we also have SQL injection. These are the three common. Up to this point, my research has not found SQL injection. I found SQL injection in all these type of things, but what I'm targeting today is leveraging the names that are processed in these systems, host names, as the injection vector. So I've yet to find SQL injection in a system using that attack methodology, but I have found SQL injection flaws in all of these products. But the delivery mechanism is a little different than what I was wanting to discuss today. But it's still something to be noted. So it turns out off-the-shelf products, these embedded devices, these software products that we can purchase have all these vulnerabilities. They have cross-site request forgeries. They have cross-site scripting. They have SQL injection. And the thing is, we're not often testing these products. Most companies that have a web presence on the internet constantly test their products, or at least they should be, for these type of attacks. But unfortunately, shrink-wrap software and embedded devices, where this server is kind of permanently built into that thing, it isn't easy to roll out a new piece of code for it. It's a little more complex. Often this technology is just ignored. Nobody tests it, nobody looks for it, until Deral comes along, or some other pen tester, other hacker, or God forbid, some malicious actor who decides to do harm to you, decides to leverage this type of stuff. So let's get into exploit delivery. We're running a little fast today. You guys need to be a little more lively.
Lined up.
Any questions at this point? No questions. Okay, good. Hopefully you have some moving forward. So let's look at exploit delivery, how we deliver exploits to these various pieces of technology. And the big one is machine to machine. This is an area that I've focused on. And when I'm talking about machine to machine, this is not where you would interact with that particular product, but where another system would interact with that particular product. This method is great for targeting enterprises. It almost creates an out-of-band style of attack. Because most of us, in most of these systems, all trust machine-to-machine communication. There's typically no direct human interaction, so no one tests these things. Another reason why I say no one tests these things. I found a lot of these products may be not vulnerable when they're directly engaged with user input. So we try to put a cross-site scripting into a product, it doesn't work. Try to carry out cross-site request forgery, it doesn't work. But when I attack that same product using a machine-to-machine communication transactions, the story is very different. Instantly, the machine receives the code. It doesn't filter the code. It doesn't look at the code. It just absorbs it, consumes it, and spews it back out, making these type of attacks very viable. The first one I'm going to talk about is SSIDs. So we're all familiar, hopefully we're all familiar with what an SSID is. We all have Wi-Fi's at our home. We give it a name. You know, it's Bob, Bob's home Wi-Fi. So you've given it an actual name. So we're going to talk about attacking using SSIDs. The description of SSID, this is called Service Set Identifier. The purpose of this is to assign a human-readable name to the 802.11 protocol naming structure, the SSID. And that way you, as a human, can understand it. It's your home Wi-Fi. Mine's actually called Net1. So when I bring up a device, I want to connect to it, I look for Net1 and I connect to it. Pretty straightforward. This is managed through broadcast frames. It's broadcast out there, and that way you can actually see it. This is the structure of an SSID information element. First byte is the element ID. This is set to 0 to signal its broadcast. We also have the length. This tells us how long the SSID field is going to be. In this case, it has a max of 32 bytes of data. So generally what you can put into an SSID is 32 characters. There is currently nor will there ever be, in my opinion, restrictions according to the IEEE standard on what you can actually put into an SSID. So literally, you can put anything in the SSID. The only restrictions I've ever seen is a few handful of products where it won't let you put, Unicode or various other weird characters in. It restricts that. But generally, it does not restrict that. It's limited to 32 characters. So I hope you all know where this is leading. A little more lively, guys. Okay, so we did some research, released a paper back in 2013, did this at Black Hat, where we're actually able to deliver attacks via the SSID name. Here's a few products that we actually did it to. Wi-Fi pineapple. Everyone in the world. Anyone here not know what a Wi-Fi pineapple is? I expect to see more names. Okay. So a Wi-Fi pineapple is a tool that's available for carrying out attacks against Wi-Fi. So with a Wi-Fi pineapple, a malicious actor can use that to trigger you into connecting to him, like your cell phone Wi-Fi to him, and then route all your traffic so he can be a man in the middle of the Wi-Fi. So we found ways to attack those people. So it was really funny. So, if somebody fired one of those up in a coffee shop, we can do all kinds of nasty things to them. But then we got into Cisco small business devices. They were also vulnerable to an attack with SSIDs. Sonic Wall network appliance, Aruba wireless LAN controllers. So we're probably getting into more names you guys are familiar with. Sonic Wall, this is an enterprise product. Aruba is an enterprise product. I'd be surprised if there's no one here actually not using Aruba products. Very popular, very good products. Since that research, I also found another unnamed Wi-Fi LAN controller device. That one was kind of scary. Same problem. This was before I was working for Rapid7, where I had to handle all of my own disclosures with vendors. This particular vendor, which is unnamed, because I have a very high ethical standard. I don't publish anything that isn't fixed. They refused to actually fix this thing unless I paid them a service fee. Fix their own vulnerability unless I paid them a service. Yes, it is real. There's like $650, we'll fix it. Other than that, you need to put in it wasn't a bug fix. They want me to put in a feature upgrade request. So they wanted me to put in a feature upgrade request to make the product not vulnerable to remote attacks.
Disclose.
No, because at this time I was dealing with a lot of companies that actually had this product. Okay, so I went to one of the companies and I talked to them and I go, you know what, guys, maybe you ought to put in a feature request. I don't know if it ever got fixed. I never did follow up on it, but it's one of those things you can encounter with vendors sometimes that don't understand the nature of vulnerabilities and vulnerability patching and disclosures. The last one is Enterprise IoT Lighting Automation Solution. I released a whole series of vulnerabilities, and there was a bunch of stuff published on the Osram Lightify. And we're actually going to demo this, so we'll show this to you today. The Lightify system, this happens to be an enterprise solution that currently is only available in Europe, eventually roll into America. I work closely with Osram Sylvania to actually get this thing patched. Great company, great to work with. They patched everything right up, really good people. But we're going to actually demo that today so you can actually see that. So the attack vectors identified deliverable via SSIDs. I list 3 of them here: cross-site scripting, cross-site request forgery, and format strings. I didn't go into format strings in this presentation. I kind of stripped most of it out. But how many people here know what a format string is? Okay. So we have a small handset. So I assume the rest of you don't. So since I left it in the slide and we have time, let me explain what a format string vulnerability is. It's pretty nasty. We found it in a number of products. We recently found it in some other products. And that's going to be published here soon. But what a format string is a format string is a specifier, ANSI specifier, it's a term right, that's in an application. So when you're writing a program, let's say you're writing in C or C++, and you define a function. Let's say that function is to print something to the screen. So you write a program that asks you what your name is, okay? and it says, good morning, what is your name? And you go, my name's Bob. And it responds back and says, good morning, Bob, okay? The format string specifier would tell within the code, that function, what the output, the format of that data is. So like a %s in that code would say output, good morning, Bob, as string data. You can use a %x and tell it to output it as hex data. I think a D will tell it to output it as decimal data. So all it does is it tells a function what format to output that data. Pretty straightforward. The vulnerability comes into place when that specifier is not defined properly in the code. So you write the same code, instead of putting the %s in there to tell you to output good morning, Bob, as string data, you leave the %s completely out. At that point, if you ran the program, it would function normal. The compile would function normal. And if you put in, it asks you, good morning, good morning, you say, my name's Bob, and say, good morning, Bob, it would still appear to function normal. Where the vulnerability comes into place is if, instead of putting literal data in there, like Bob, I would put a format string specifier in there. So when they ask me what my name is, instead of putting in Bob, I would put in %x, %x. What the program would do, instead of validating that as literal data and outputting it as string data, it would assume that it is a format string specifier within the code. At that point, it would function, it would take that as code instead of string data. At that point, it would go to the process stack. It would read data off the process stack, looking for the data like your name would be, but it would only find raw code, raw data on the stack. So it would actually output raw code off the stack. And then you can use like %s, which would enumerate that pointer on the stack, or that data on the stack as a pointer in memory, and then it would go to memory and start dumping memory out to you as your name. So as you can see, you can read data from the process stack with this vulnerability. You can read arbitrary memory, and you can also write to arbitrary memory. So you can see it's a serious flaw. They're very rare. You don't come across them that often. But over the last couple years, I seem to find at least one a year. It seems to be the norm during my testing. So I still test for them. So hopefully that explains the concept of a format string or format string vulnerability a little better. After this, if you want to talk about that more, I can actually share more. So we have a couple demos. Now we've talked about using SSIDs as an attack vector. You really don't get it until you see it actually happening. So let's go ahead and show the first one. So the first one we hear is going to be against the ArchCon. This is fairly quick and short. So we're going to log on to the ArchCon console. This is the ArchCon management console. We're going to come down here to where the wireless settings are done, where you can interact this device with the wireless. And now we see the SSIDs, the names. These are the names being broadcast to machines on your network. What we're going to do is we're going to fire up a soft AP where we're going to give it a special name. This is the actual name that we're going to use. And then we're going to go ahead and look for it. So it makes for a really unique reaction, to say the least. So as you see, we can actually inject some kind of code into the user's web browser. We look at that and go, yeah, that's funny, what's the risk? So you're told. But if I can inject that code, I can inject almost any code, web-based code, into the user's browser. And it can get really serious. So the next demonstration I'm going to show you, I think, brings that to light. This one takes a little longer. We got 3 screens. Let me describe them as this thing goes around. The screen right here is an FTP server. It's a separate VM that I'm looking at there. This here happens to be the console of a Aruba wireless LAN controller. This is several years old, but we all typically use wireless LAN controllers in our environment. This one here has like rogue AP detection, or rogue access point detection. So we're actually going to give it a rogue access point to look at. Okay? Up here happens to be another VM we're actually going to fire up Assault AP, where we're actually going to point it to some JavaScript that we have running on the server. Now I kind of lost this JavaScript stuff. It'd been nice to show you what it looked like, but basically what it's going to do, it's going to tell this device to carry out a couple of cross-site request forgery type attacks for us. So let's see where we're at. So I'm poking around here. So here is the page where you would see the rogue access point detection. Now think about this. Where would you see this screen showing maybe all the time? Typically in a SOC, the Security Operations Center, may be constantly monitoring for rogue access points. So if they were monitoring for rogue access points or other access points that are interfering with the corporate network, there could be some issues. Right there, we see the SSID names. So you see where the name of the presentation comes from? It's all. So we're going to check right here and make sure there's nothing there. So I have no files there, pretty straightforward. So I'm going to kick this off here in a second. No Vanna White thing. So when we kick this thing off, I wrote the code not to be obfuscated. So something's going to happen. Bang, something just happened. And I wrote it specifically to do something. So you can see something happen. Well, if we look over here, this third-party FTP server, this device just sent us this entire running config. That was a process within the device that said, back up your running configuration to a third-party web FTP server. So we did. And we did it with an SSID. So now we have the entire running config on this device. And now we're going to jump back over here in a second. Configuration. So now if we look into configuration, and earlier I showed the actual administrator account. Now we have another account, Evil Hacker, with root level privileges on the device. So we're able to basically, a vulnerable product here, where it processes, it doesn't properly filter the name data. Common cross-site scripting problem. In this case, it's not filtering that name data. It's allowing us to input cross-site request forgery data, cross-site scripting type data attacks within the console. So when this thing's being monitored live within a data center, all we have to do is fire up our own access point containing the attack data. It immediately is enumerated by the Aruba rogue access point detection solution, and it shows us what the SSID is. In this case, it renders it as code. The code in this case was 2 blocks of code. One block of code said, create an ID with root level privileges on the device. The second one was FTP to your running config to a third-party site. This type of attack via SSID does not have to be on your network and can be remote. The attacker only needs to be sitting in the parking lot or anywhere that machine is detected at. Any questions? What's that? Yes, it's been patched. It's been patched. The funny part of Aruba is when I actually found this vulnerability and I contacted them, they go, "You're crazy. We patched that 2 years ago." Apparently, they had silently patched it 2 years ago, but they had inadvertently rolled back out the same vulnerable code block into production code again. So yeah, I mean, he didn't use any bad words when he described me. He basically was like, "You're crazy, you're full of it, you don't know what you're talking about, that's patched." 6 hours later, "I'm sorry, you're right." And then he explained to me what he had done, or what they had done. And of course, working with the companies, we get a couple good benefits out of this. The reality is one, they get the product fixed. Two, they find out they have a problem with how they manage the code to avoid rolling out more vulnerable code. So some good fixes were there. And again, it makes for a good example of explaining to you guys this type of attack vector. Because remember, like I said, remember the one slide I had up there with all those web servers. This is basically a browser managing this product. This is an appliance. It's running its own web server. You're logged in with administrative privileges. If that thing doesn't properly handle and filter incoming data from machine to machine or for users, what's the impact? In these two examples, the first impact is you get rickrolled. The worst case scenario, you get your credentials changed, stolen, reconfigured, running configs taken, a whole list of potential attack things could take place. Did you like that?
Yeah.
You are quick. Nothing wrong with that. Nothing wrong with that.
Which pineapple versions are still vulnerable?
What's that now?
Which pineapple versions are still vulnerable?
All pineapple versions are vulnerable.
Always?
Yeah,
They only fix some of those versions.
So that they came out, the funny thing, if you remember the Pineapple 5 came out
Yeah.
a year ago, a year and a half ago.
Yeah.
It was really sold at DEF CON.
Yeah.
They sold literally hundreds of them at DEF CON. Apparently there was vulnerabilities in it at the same time, and somebody fired up basically an SSID style attack against them and actually formatted everyone's device. So that it wiped the entire operating system off, every device that powered up.
Oh, that's awesome.
So yeah, it's like tons of vulnerabilities within the product. So I would assume that it is vulnerable and always vulnerable. Now I could be wrong, but so if you're going to be doing anything with one of those things, just be aware it could have issues. But I haven't tested it. I had a 5. But I never used it. I had to pass it off to somebody else on the team for use. So the next area we want to get into is SNMP, Simple Network Management Protocol. Another vector for delivering attacks into systems. This one here to me is pretty bad. It is a bad vector. Our research has shown some serious flaws on multiple products. But Simple Network Management Protocol. It's real simple. A couple key areas to remember with Simple Network Management Protocol, a couple terms. Management Information Base, the MIB. The MIB, that's the data. That's the database within SNMP that exists on a device. Okay, and that contains all the information about your device, the functions of your device, ongoing counters, all that information that you can actually query. And the way you query it is via an object identifier. An object identifier is a pointer within that database. So I can make an OID request via SNMP and query specific pieces of data within that structure. I can ask it how many interfaces do you have on Ethernet. I can ask how many packets that you process via SNMP. The list goes on and on of the different information that may be available via SNMP. But what we're going to do is we're going to leverage something about SNMP, specifically in reference to devices that consume data from your appliances and network devices. The things I'm interested in are the naming structures, the names. How do we deliver attacks in names? These are the OIDs that specify these type of fields: sys description, sys contact, sys name, sys location. These are often the pieces of data on all network management systems. We either use some or all of these fields. And I'm assuming if you're in a fairly large organization, you have some form of a network management system on your network for managing all the devices on your network. You use that network management system for running queries. You'll have it run scans of your network to identify new devices that have been added to your network. When it does that, it's going to consume these. All of these are part of these. And what is it going to do with those? It's going to make them all viewable via the web management interface. Potentially, if not properly filtered, is going to give us another attack vector into your products. So we started this research in fall of 2015. I worked with a friend of mine, Matthew mainly targeting network management systems. Just looking at network management systems as an attack vector. And mainly just looking at using these four fields here for delivering SNMP based attacks of cross-site scripting, cross-site request forgery, format strings, SQL injection, anything that we could do into those devices using the naming structures that are currently available within Simple Network Management Protocol. Last year we published 4. I published 1 more advisory. We got 4 more getting ready to release before DerbyCon. How many people are going to DerbyCon? Oh, come on. 3, 4, 5.
He sold out.
You can still go.
You can always still go.
You can always
Yeah.
go.
Just get a hotel room. There's a party.
Yep.
We know how that goes. So, yeah, there's, tickets will still show up. Don't, not to diverge, but if you're interested in going to that conference, the first thing I tell people is, as soon as you find out that it's going to be at the same hotel, book a room. As soon as the rooms come available, book a room. If you don't get a ticket, people, as you get closer to the conference, are going to go, oh crap, I can't go. My wife's getting ready to have a baby. I'm getting married. My brother's getting married. The list goes on and on and on, and tickets will start showing up. If you have a place to stay, you'll be able to get the tickets and go. So, I have 2 tickets that I'm eventually going to sell. So we're going to be releasing a white paper over the next couple of weeks that covers this whole attack vector in detail. A total of 9 different products, which is about probably a little more than 50% of the products we looked at. So every time I load up a network management product, it was a little better than 50% that I was going to be able to carry out cross-site scripting attack, cross-site request forgery attacks, format string attacks against these products, leveraging SNMP. And the way we typically did it is all of these products are capable of consuming SNMP data in 2 vectors. The first vector is the discovery vector. You scan your network once a week, twice a week, once a month, whatever, for new devices within your network management system. All we have to do is plant a device on your network and wait for you to scan it and consume the data. And we just put evil data into those fields. The other one we found out was SNMP traps. We found out out of these 9, I think we had 6 of them that would take this attack vector via SNMP traps. So all we had to do was just send the trap packet to it and carry out this type of attack within these similar fields. And 4 of them, I believe, had unsolicited traps. That means it doesn't matter what my IP address, it didn't matter what my SNMP community string was. I just sent a trap to it and consume it and display it on the management console. So pretty bad attack vectors. So again, the best way to describe this or show this to you is using a demo. This product here is SNMP-C. This was, I believe, called Castle Rock. It was some software. It was interesting. As we started this research, I constantly would engage people like you and ask you what SNMP or what network management system did you use in your environment. And then what I would do is I would go home and download it and start playing with it. In this case here, I'm not going to say who it was, but once a certain state government was actually using this product. So I got home, fired it up, started playing with it. Let's go ahead and fire this up so we can see this attack here. I'm going to log into it. We're going to show you what it looks like. If I can log in. You think I'd make a better recording, Nothing worse than failing on your own recording. So as you can see, in this case here, we don't have a big network. We have a small couple network subnets. So we have a subnet here. Pretty straightforward. We have the one device, but we're going to have it scanned for another device. Now this product had two interesting pieces. It had the web management piece, and it also had a hard-coded piece that was not web enabled. So what I want to do is I'm going to show you our attack platform. This happens to be running SNMP-D on a Ubuntu environment. And all we have to do is take the SNMP config file, and we would actually put the code in here. In this case here, we're actually calling some JavaScript off another web server. Look at the JavaScript. The JavaScript is going to run this right here, which is going to call another piece of code, PHP code, and it's going to actually pull the document cookie. Document cookies are the session-based cookies associated with the authenticated user. So when this executes within the context of the authenticated user, he's not going to see anything. Everything's going to function normal. No alerts whatsoever are going to take place. But what it's going to do, it's going to pull his session cookies, send them to my server, and my PHP program is going to write into a file for me. And here I just did a dump, an SNMP dump of our configuration file or from the device. This is what is going to be seen when this device is consumed. So in this case, we're going to log into the hard-coded management product because that's where you actually configure most of this. The web management thing is usually for just reporting purposes and functions like that. We're going to go ahead and point it to just the device on our network. And typically this would be coded in there to run like weekly, monthly, whatever the case, to find new devices on your network. But in our case, we're just going to point it to the specific IP address to kind of speed things up. So we kick that off. It instantly is going to start scanning pretty quick. And we come over here and we see the device showed up. So it showed up here. And of course, I'm going to jump over here because I'm going to show you real quickly the actual tip file folder where we're going to write data. And there's should be anything there. So we do a cookie. We check, make sure there's no file there. There's nothing there. So we want to make sure there's nothing worse than writing the demo and the data's already there. It's kind of bad. So we look at it, and so we click on it. So all the user does is click on it. He drills down, and if you see, nothing happened. Even our code didn't break the page because we wrote it not to. Page is normal, no indication. But now we have a cookie file on our third-party website, and we have a session. To make matters worse, they didn't use session cookies. They actually used the raw username and password for the session passing data. So not only do we have, it goes beyond just having the session cookie. Remember, if you're communicating via web functionality and authentication, if a session cookie gets compromised, all you have to do is log out and back in and you get a new session cookie. Okay? Compromise can be restricted to a short period of time. Hopefully you detected something went wrong and you can fix it. In this case here, we just gave up the entire password, username and password within the session code. So did everyone see that? Did everyone understand what took place there? Okay. So literally, by putting a device on the network, just drop in any device. This could be literally anything. It could be everything from a Pi device, any small device. Just plug it into your network. DHCP serves up an IP address to it. Your monthly scan comes along and scans your network. It sees this device and consumes the data. If you actually are using the device, I would assume your administrators can go, hey, here's some new devices. I wonder what it is. And he's going to click on it. He's going to look at this data and he's going to go, I really don't see nothing wrong with this. I don't know what it is, but, and you can actually give it a description name that's realistic. But everything looks normal. Unbeknownst to him, all of his administrative creds have been passed off to a third-party website somewhere. And down here, we kind of opened up the web page. As you can see, our JavaScript. I'm fine here, so it's dead. Somebody shut it off. Okay. Well, we can continue on, Paul, so we'll figure that one out. So the next slide
That was a powerful.
isn't really that important. So the next slides aren't really that important. I just want to talk to you. So the next section, I want to talk to you about hosting. So we talked about, and the slides are really important. So we looked at SSIDs as an injection vector. So SSID is a name. It's a valid injection vector. And I guarantee you there's devices on your network full. We just haven't found them yet. Okay? Because I can't look at everything, but it seems like 50% of the time I find stuff when I look at products. We can also deliver via SMP. And we've shown that attack vector to be seriously vicious against network management systems. It's also vicious against other products, which we tested against our own products that were Rapid 7, and we're able to fix those issues that were discovered. So about 50% of the time, any device that consumes SMP data, those 4 OID data points, and displays them with the web console, is vulnerable to those attacks. So then we get to this one, host name. Now this was kind of funny. Well, this started off the host name part of it. I was on an engagement with a coworker, and he was running a tool that did relay attacks on the network. And what it would do, it was just pick up data coming from a machine, and it would try to relay that as an attack. And I know he was running the product, and it grabs everything, even other machines, even your machine. So I renamed my machine to contain JavaScript. And the JavaScript said the script tag, alert, brackets, I pwned you, /script tags, and I fired it up. It only took about 5 minutes. I'm hearing scream from the other side of the room. Ah! Apparently, the product he was running was vulnerable. So he got this big pop-up basically saying I was pwning. But I didn't write it to actually do it cleanly, so it basically bricked the entire database from the product that he was doing. So he couldn't use it anymore. So he's kind of mad at me, so he had to reinstall everything. So I thought it was funny, but that's the way it goes. So from the host name, literally the host name, what would happen? I mean, think about this. What would happen if you changed your host name on a machine on your network to contain some kind of code? Whether it's format string specifiers, whether it's cross-site scripting attacks, what would happen? Now think about your network and think about every machine or every product that you log into that potentially shows the host name of the systems that is interactive. Whether it's logs, we look at logs, do we look at logs for the web browser? That could be interesting. Is it an embedded device? Is it your DHCP server that keeps records of all that stuff? Do you interact it with the web server? I mean, the list of possible vectors is astronomical. Even though host name has no value on the network, it is often consumed and displayed in a lot of products within the IP address. Now, I've not tried this, but I put out a challenge on our website, on Rapid7's website, earlier this year, and wrote a blog about it, and I challenged people to find out. So I challenge you to find out, but I warn you. Hopefully you have a lab. You know, within your lab, you may have various copies of your products. Often you can just use iframe tags, you know, less than, iframe, greater than, and just use that in the host name. Now you can change the host name on the Windows box. It's really hard. It has to be done through the registry, so I went through it to a production box. But it's doable. And you can do it on Linux boxes also. You can change the host name, and I would put that in there. But I would only do this in your lab. Because literally, you could brick stuff, okay? And I've done that. So do it in the lab and see if any of the products that you are running are vulnerable. If they are vulnerable, let me know. Or, you know, if you have a contract with that company, contact them. But I'd like to let me know, because I'm trying to build some statistical data on that. I don't have access to everything in the world. But it'd be nice to actually find out if this issue, these vulnerabilities, continue on and can be leveraged via just common hostings. Do you agree?
Yeah.
Okay. So think about your environment, what products you have. I mean, like I said, I told you before we started here that you would look at the host name of systems on your network quite different after this presentation. And that's my goal. I'd like for you to do that. Don't do that live in production. Do it in a closed lab because you can have some adverse effects on the applications. And it's fine if you destroy or break a page on an application on something in your lab because it's not production. So that's fairly harmless. But if you fire that up on your actual network, the side effects can be pretty bad. If you happen to have some kind of appliance on your network that actually consumes that data and logs it, which I did one time in my lab. I had actually an Alcatel switches that were vulnerable to attack I had, and I literally bricked the entire web interface on an Alcatel device through one of these style attacks. And so the web page was just garbage. The whole site was garbage. I had to reinstall the entire firmware. So that's fine to do in the lab because you can reinstall the entire firmware. It's not an issue. You don't want to do it in production, so that's a warning. So we're kind of closing in on the end. Do you have any questions?
What other,
Yes.
How do you do it like phone-based attacks? The SSID?
With what now?
For the SSID, like phone-based attacks?
Oh, against phones?
Yeah.
If you remember here about 2 years ago, there was a string of Arabic characters and you crash an iPhone.
Yeah.
And there was this thing, the whole thing went off on Twitter going, hey, you could actually pass this via SSID. The answer was no, you couldn't because it was 50 characters long, okay, 32 characters. But, of course, me being who I am, I sat down and literally converted all that into all of its Unicode code and stripped it all down to 12 characters so that you could. And then I published that. So yeah, at one point, yeah, you could literally come in and fire up an access point and crash everybody's iPhone in the room. Did I do that? No. Did I do that stuff to my coworkers? Yeah. but in reality, yeah, can it be done? Have I tested phones? I've done limited testing with SSID attacks on phones. It really comes down to the applications that consume that data and what kind of attacks would work within those applications. If the application can be attacked in some way, then yeah, that is a reality. You could potentially do that, but there's been no formalized research around trying to do that across apps. I mean, there's so many applications for phones out there that may consume this type of data. It's astronomical of the possible attack vector that could exist there. So there is the, I think that's the blog that I put out there where I put the challenge out, and that's our PGD key. If you do find something like this you want to share with us, obviously we would go through ethical disclosure if you wanted us to do that, and then give you credit for it. Obviously, we don't want credit for it. But there's a way, if you actually find host name attacks against appliances on your network or products on your network, you can share that with us, and we can help disclose that with the vendors and get it properly patched if anyone's interested. What was the other question?
Oh, I was just going to ask if there was any, what other consumable piece of information you found trying to serve
Consumable information. So far, I mean, these projects, most of these projects were done on personal time. So a lot of time went into these, a lot of products. I'm talking the SMP network management systems. You're looking at labbing up fully functional products in a lab, like 10, 15 different products over 6 to 8 month period, and going through and testing every possible vector into that with that data, and then testing every possible screen where that data could possibly be viewed. Because in some cases, they may have properly filtered data showing up on certain pages, but then they would miss one page. We had one product that literally my co-conspirator tested in his lab, found nothing wrong with it. I brought it into my lab and I found something. Because he happened to miss that one primary page where the data was injectable into it. So it's very time consuming to be thorough on these products for this. So those typically where we've done the SSIDs, looked at a lot of appliances, software type of thing. I continue to look. So every time I engage a new product, a new system, I will test it for this. Literally, I was at a company meeting in January, February, our company kickoff, talking to my current boss, and I asked him about how does Nextpost consume data from multifunction printers, because it's difficult to fingerprint multifunction printers, and the way they're fingerprinting multifunction printers is kind of using S&P data, because it's always public. That way the printer continues functionality, and it's a key identifier of what that printer is. So as we were talking about, you know exactly what's going through my head. I'm like, evil. So I went back to my lab, and first thing I did was lab up the product, and I tested it. And the product handled it really well for everything except for one page. And we were able to inject and attack into that. Immediately the product team jumped in place and fixed the whole thing, and then they gave me permission to actually use it in demonstrations and stuff like that, to kind of show that, we do the same stuff against our own products, and then test those too. So, and we're not ashamed of that. Every product, every vendor, every type of device out there either has, potentially has, or will have vulnerabilities. So the goal is to find those, fix those before the bad guys do. And that's kind of the driving force around a lot of the stuff that I do. Any other questions? Well, I think, one more. Yeah.
Just real quick, when you find a vulnerability, is that reported into the Nextpost product for like website or one of the Nextpost where you can use the scanner to find those?
Yeah, a lot of vulnerabilities will get put in there, but a lot of times it's also, can you fingerprint or identify whether that would be vulnerable? So the answer to that is yes. Do all of them get over there? Not all of them are easily identifiable in a scan that it's a vulnerable product or not a vulnerable product, but if it can be, then yes, that is ported into the product. Well, thank you very much. I hope you enjoyed it.